Okay, all right. So first part of this Snakemake course, we're gonna start by talking a bit about reproducibility. So that's why I'm glad it was one, maybe the main keyword of the word cloud you made. And then we'll start talking a bit about Snakemake and the very basics of Snakemakes. Then there'll be a short exercise session about all of this. Um, and yeah, that's the program for now. So back to your phones to vote. So first question is for you, what is reproducibility? So that's several definitions, and last answer being that all of these statements are equivalent. So yeah, try to read and vote. So let's wait a few more seconds. Okay. All right. Interesting. So that's yeah, no, that's so interesting. So most of you actually consider that these definitions are equivalent. They're technically not. Like the true definition theory of reproducibility is the third one, to take existing data, rerun the same exact analysis, and produce the same exact figures, statistical findings, and everything. The difference between the three statements is actually replicability, so first statement versus repeatability versus reproducibility. But I mean, for this course, we'll settle with a definition that I quite like because it's more or less vague. Reproducibility is more or less the ability to draw similar conclusions from replicate studies. And as you probably all know, it's one of the key components of the scientific method, a cornerstone of science. And in theory, if your data are not reproducible, you shouldn't be even able to publish them. But that's not the case today, unfortunately. So do you all think, like, what's your take on reproduce on the reproducibility crisis? Is there a crisis, a big one, a small one? There is no crisis. You don't know anything about that. Um, if you're here, you should already have, let's say, some ideas and opinions about this. So it's good. Most of you are aware that there is a significant crisis in reproducibility. Um, if you're If you voted no, I'd be curious to have your take on this now or later, or we can discuss it afterwards because I'd be very interested to know why you think this. But unfortunately, yes, there is a huge crisis in reproducibility. So this a few numbers for you. So this study is beginning to be quite old, but unfortunately, it still stands true. They surveyed roughly 1,600 researchers. 52% of them found a significant crisis, and 38% of them slight crisis. So that's 90% of these researchers that think there is a big a crisis going on. And then, so that's a PI that's doing meta-analysis with his team. So he's working mostly in ecology, but he made some really interesting articles and videos about the publication bias. And in one of his studies, they found so they surveyed 83 articles of three different fields, only 30% of partial replication and 0% of true replication. That means over these 83 articles, they weren't able to reproduce to fully reproduce any one of them, which is very worrying. And and the last one, so this has changed a bit, fortunately, but it's still not a gold standard nowadays. But usually, when you publish, the editor should should ask about reproducibility statements and so on. And numbers are a bit better nowadays, but it's still not there. So one question we can ask is, why is that? So do you have any Do you have any ideas of why reproducibility is so low? Like, feel free to take up your mic and talk if you want. Yes, Sebastian, go ahead.
I think part partially just kind of a systemic issue in that very few journals still require or actually, expect or publish methods, scripts. So I think, it's just the baseline expectation, I think, has been quite low. It's partly generational as well. So
Yeah.
I think that's a huge contributor.
Yes, exactly. And Katrina wrote in the chat that people don't even give details on how they analyze data or created figures. That's also very true. Usually it says, hey, I just analyze my reads and map them to whatever genome, like no mention of the software, no mention of the version, no mention of the parameters, and so on. Um, and yes, well, sometimes you can't, but you should make your code available. In theory. Uh, Tessa?
Yeah, at least for myself, I think a lot of the work I do is ad hoc. It's very reactionary. Somebody asks a question, you do some analysis. It can be very hard to track things then. I think that's also part of it, and the fact that there's no requirement to do so either for publication. So
Yes, exactly. So that's a study like was published in eLife 4 years ago. They tried to produce a lot of results as well, and they benchmark basically some criterias over like whether others help, where the reagents or the code shared, and so on. And what they found is that there is as Sebastian said, a systemic absence of knowledge infrastructure. There are also some questionable research practices and fraud. So this, unfortunately, we can't do anything because if someone wants to cheat, they will cheat. Like we can't prevent this. We can only detect it afterwards, uh, if we're lucky. Um, there are some statistical issues as well. For example, when you've got low statistical power, heterogeneity. So publication system in science is biased because you often don't publish negative results. You don't often publish reproducibility results, even if that would be very extremely useful. And sorry, so Parvanet uh, says like it should be a good idea to determine minimum criteria for publishing any test. Yes, like hopefully we'll get there someday where there are like some minimum criteria that you should match to publish, saying is the code available, for example, using Zenodo. Is there an easy way to reproduce all the results and recreate all the figures and so on? That would be a great improvement compared to what we have now. And so yeah, publication bias, also the obligation to publish or perish, so that leads to lots of publication, often decreasing the quality of the papers and the reporting of standards of reporting, because most papers today are still not open access, and that's a big problem. So what we can deal with, at least today, is a standard of reporting, like share your code, share your analysis, share your data, things like this. So this we can act on, and that's what we're gonna talk today. And so that leads us to workflow management systems. So, how familiar are you with either workflow management systems or specifically Snakemake? Okay. Okay. So most of you will learn a lot today. That's good. For the more, let's say, advanced users, we also have some, I think, pretty nifty usages and info on it. We have some extra and optional exercises as well. So if you feel you're doing things too fast, like feel free to do the extra steps that we mentioned on the website. Hopefully, this should teach you a bit more as well. So WMS can solve several issues, including hidden issues, at least partially or sometimes entirely. So entirely, when we're talking about the OS, the versions, the code language, readability, availability, when you combine WMS with containers and package managers like Conda, you can solve a lot of problems. You can also partially solve the issues of file formatting, metadata, parameters and options that you used. So that helps a lot. The idea behind all this WMS is to provide a reproducible and also scalable infrastructure to set up, perform, and monitor a defined sequence of tasks. Usually it's a series of tasks, so you go from point A to point B with some intermediary steps. You can use it for other things, but that's the main usage. So the three main workflow management systems right now are Nextflow, Snakemake, and Galaxy. So Nextflow is coded in Groovy, which is kind of a Java superset, Snakemake, which is an extension of Python, and Galaxy, which is, interestingly enough, Java plus Python underneath. What's interesting with Galaxy is that it also allows non-bioinformaticians to do some bioinformatics analysis because it has a graphical interface. How now, like the execution system, like how are the tasks organized, run, and so on. In Nextflow, most of the process will have to join them manually. In Snakemake, it will try to automatically resolve dependencies between inputs and outputs using pattern matching, sorry. And Galaxy is a web-based GUI, so you can manually organize all those tasks. And as I said, like the great thing is that you don't need programming knowledge. So that's a nice entry into this world. So of course, today we'll focus on Snakemake, which is relying, so as I said, on Python. So quick poll, and that will be all for this session. How are you doing with Python? Yes, more?
I'm just wondering about the previous slide when you showed the different I never worked with Nextflow, but I was wondering in which cases you would opt to use a Snakemake or you would opt to use Nextflow instead. Because it's also widely used, the Nextflow, and I keep wondering if I'm missing something there.
So I think I'm not sure there is an actual, let's say, scientific or code reason or like scientific reason to use one or the other. What I've seen, so once again, personal experience, but what I've seen is that Nextflow tends to be adopted by companies and private sector, while Snakemake is most of the time used in academia and hospital research and things like this. I don't know why there is such a bias, to be honest, but that's what I've seen, or at least what I feel. And also, it can depend on your coding skills. Like if you're fluent in Java, Nextflow might be an easier entry into this, while if you're fluent, like if you know Python, then Snakemake might be easier to take. But yeah, I don't know if like Rafael or Juna, you have some take on this.
No, I agree, man. I think both are very valid. I mean, in the end, it's a matter either of making a choice or trying to learn both, like some people here are doing, which is really a great option as well to know both.
And another thing is that sometimes you start a new job and everybody's already using the same workflow management system, so you have to learn it and you got no choice. That's also something that happens. Right. So about Python. Okay, so nice to see we've got some coffee addicts in the class. All right, so most of you are already pretty handy with Python, so that's good. Okay, all right. So a few interesting features of Snakemake to tease you a bit. So it's Python based, which means it's most of the time concise, quite readable, and also user friendly. You can easily use it and execute it locally, so on your laptop or on your desktop, or remotely in the cloud, computation clusters, things like this. You can use it has an integrated package management system with container member, and also Docker, like a container deployment system with Container. And in the end, once you download the workflow, if it was coded properly, it's very easy to run it in a control environment and to reproduce automatically all the results, analysis, figures, and so on. So now you may ask, how does it work? Like, what's the core principle in Snakemake? So as we said before, a workflow is a network of dependent rules, meaning some rules that will interact together. So in the scheme, like, the rules are green, and the rule is the basic block, the building units of a workflow. It's a set of instructions to create one or more outputs, so in gray, from 0 or more inputs. So for example, rule 1 takes one input and create one output. Rule 2 just create an output. So for example, rule 2 could be downloading the data from a remote website, GEO, things like this. You have no input, but still you create an output. And rule 3 has two inputs, sorry, and create one output. And so here you can already start to see that files can be both inputs and outputs at the same time. A job is the execution of a rule with specific inputs and outputs. So a job is, okay, I will execute rule 1 with file.txt as input and file2.txt as output, so precise definition of the file systems. And Snakemake will consider that the job is successful if it shows no error during the processing and if all the expected outputs are present. When an output is missing, so for example, even if you expect 10 outputs, if one of them is missing, Snakemake will consider that the rule has failed. And finally, all of this will create a DAG, what we call a DAG, a directed acyclic graph. And it's resolved from the required outputs, meaning that in the end, you will ask for the outputs, and Snakemake will go back up to try to find what it needs. So in this case, okay, you ask for output 3, and Snakemake will understand, okay, so to create output 3, I need outputs 1 and 2. How do I create output 2? I don't need anything. How do I create output 1? I need input 1, and so on. Why is the DAG useful? Because it's a core principle of Snakemake. One, because you can skip part of the DAG to avoid recomputing. So that means that if, for example, if you already have the files, Snakemake won't recompute them. So it saves you time, resources, like you don't waste CPU hours, you don't waste memory, energy, money, and so on. You can also change and add some inputs, some rules to existing analyses without rerunning everything. So when you've got very large workflows, it's super useful. And also, because let's face it, we all had some workflows or scripts that crashed. When a workflow crashed in the middle or partway, you can actually restart it without computing everything once again. So pretty useful. And so if you wonder what does Snakemake really look like, that's an example. So we'll get a bit more into this, but usually you've got a rule with a name, input with a path to the input file, the output and its path, and some other directives. So to give you some lingo and somewhat of a cheat sheet. So this, like the rule word, is actually a Snakemake keyword. There are several of them. In black, it's a rule name. It's user-defined, so it will be your choice. The things in yellow, orange are Snakemake directives. So for now, only 3 input-output shell. We'll see many more during the course. And each directive has one or several values. It can be an object in the sense of a Python object. It can be a string, like a file path. It can be a command with some instructions. It can be some numeric values. We'll see this later. And we'll talk more about wildcards and placeholders in the next session. So won't dig into this for now. But what we're going to do now is try to understand the structure of the Snakemake workflow, create your first rules, your first snake file, try to chain some rules together, and also run your first workflow.